Okay, next is linear programming. Linear programming is also related to limiting factor analysis, but it is a big topic in itself. So that's why I did a separate video on it. Remember, limiting factor analysis we already saw in throughput accounting as well. Limiting factor analysis relates to make or buy decision as well. Make or buy decision with limiting factor, it relates to outsourcing as well. Linear programming is especially used in a situation where we have more than one limiting factor. So far we saw that there was one thing that was limited in organization. Now in linear programming we will see more than one thing being limiting factor. And linear programming only works if we have two products, not more than two, not less than two. Because we will be preparing graphs, and on graphs one product will be put on x-axis, another product will be put on y-axis. And you don't have to worry about graph in F5 because there is no way in computer-based exam that you will be able to prepare graphs, but you just need to understand. So as I'm answering the question in linear programming, I will tell you what could be asked in exam, what is possible in computer-based exam to be asked. So don't worry about doing the whole thing in exam. Me doing the whole thing is so that you understand each of the steps. So in exam, understanding is important in linear programming. You don't have to prepare the whole thing. Okay, so let's directly jump to the question. That is my style. I believe the best way to learn topics is through questions. Okay, so this is a question from past paper. Let's look at the requirement on graph paper provided. It is taken from the past paper. When exams were paper-based exams, you were provided a graph paper on which you had to prepare the graphs. Now that the exams have become computer-based exams, so that graph paper or preparing graphs is not relevant. You only need to understand graphs. Use linear programming to calculate the optimal number of each product, which tablet co should make in the next quarter, assuming it wishes to maximize contribution. Calculate total profit for the quarter. Calculate any amount of slack resource arising as a result of optimal production plan and explain the implication of these amounts for decision making within tablet co. Okay, tablet co makes two types of tablet computers, Zeno and Yang. One is X and another is Y. Sometimes X and Y is given. Sometimes you have to name products X and Y yourself. X currently generates a contribution of 30 per unit, and Y generates a contribution of 40 per unit. There are three main stages of production: the build stage, the program stage, and test stage. Each of these stages require the use of skilled labor, which due to a huge increase in demand for tablet computer over recent months is now in short supply. The following information is available for 2 months, two products. We have the minutes per unit for each product, and then the cost per unit of each stage, the build stage, program stage, and test stage. So data for each stage and each product. Tablet Co is now preparing its detailed production plan for next quarter. During this period, it expects the skilled labor hour available will be 30,000 hours, which is 1.8 million minutes. For build stage, 28,000 hours, which is 1.6 million minutes. For program stage, in 20,000 hours, 12,000 hours, which is 20,000 minutes for test stage. The maximum demand of X and Y over the next 3 period is expected to be 85,000 units and 66,000 units respectively. Fixed costs are 650,000 per month. Due to rapid technological change, the company holds no inventory of finished goods. Okay, let's directly jump to the solution. Okay, there are about 6 to 7 steps in exam, depending on requirement of the question for linear programming and what you could be asked in exam to prepare those steps. I've already taken this data and I've written it here as well. just so that it is a little bit near. The first thing we do is we identify variables. So one thing is x. The unit that should be x should be identified. In this question, it was already identified. Zeno was x and Yang was y. So in some questions, it is not told. You have to specify which product is x and which product is y. And C would be our contribution of x and y. So three things: x, y, and C. And next is our objective. Objective, remember, of limiting factor analysis is to maximize contribution. Contribution in this example per unit was 30 for x and 40 for y. So we want to maximize contribution, and contribution equals 30x plus 40y. Next, we want to identify constraints, things that are limited. We had build time, program time, and test time that was limited. 1.8 million minutes, 28,000, 1.6 million minutes, and 720,000 minutes. So build time is limiting factor. So it can be equal to or less than 1.8 million, and you have to show it in an equation. 24 for x and 20y. So 24x and 20y can be equal to or less than 1.8 million minutes. Do the same for others as well. Next is program time, which is 1.6 million minutes. $1,680,000, and it is 16 and 14. 16x, 14y. Next is test stage, doing the same, but test stage is 720,000 minutes. So remember, this is not less, it can be equal or less. So there is no sign for it here, so I'm just underlining it. And it is 10 and 4. Doing the same thing for sales. Remember, sales were limited to the maximum of 85,000 x, 66,000 y. So x can be equal to or less than 85,000 and y 66,000. Okay, next we draw a graph, which means preparing data for graph. So what we do is we take all three resources without the sales constraint, the resources constraint. We want to know, for example, for build stage, if we only make x, how many units of x can be made? If we only make y, how many units of y can be made? So let number of x, y equals 0, x units would be 1.8 million minutes divided by time taken by x, which is 24. It would be 75,000 units of x. If we only make y, it would be dividing by 20, 90,000. So we could make 75,000 units of x or 90,000 units of y. So we put this on a graph. I've already made graph here because it is not relevant to exam to prepare a graph. You just need to understand. So I've y-axis and x-axis, I've put numbers here, and then I've written thousands here, which means that each of these numbers is 10,000. So we have 10,000, 20,000, 30,000, and the same thing goes here. So the proportions of x-axis and y-axis in linear programming should be same. In CVP analysis, we saw it didn't matter, but here it is important that both of them are the same. So we saw here from 75,000 units of x to 90,000 units of y. So we draw a line that goes from 75,000 units of x. If here it is 70,000 and here is 80,000, somewhere here would be 75,000. So we draw a line that goes from 75,000 units of x to 90,000 units of y. So y, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 75,000 units of x to 90,000 units of y. So we do the same thing for two other resources as well. Okay, now let's look at program stage. And it is 16 and 14. So 105,000 units of x to 120,000 units of y. So if here is 100,000, here 110,000, around here would be 105,000. If here we had 90,000, then 100,000, 110,000, and 120,000. So from 105,000 units of x to 120,000 units of y. So this is our program stage line. Next is test stage. 720,000 divided by 10 and 4. So 72,000 units of x to 180,000 units of y. If here is 70,000, here is 75,000, around here would be 72,000, somewhere here. And then if we have 120,000 here, 130, 40, 50, 60, 70, 80. So from 72,000 units of x to 180,000 units of y. And then sales lines, 85,000 units of x, 66,000 units of y. They are just parallel lines. So we have 75,000 units of 75,000 units of x, sorry, 85,000. Yeah, 85,000 units of x, parallel line. And 1, 2, 3, 4, 5, 6, 65, and then a little bit higher than that would be 66. Let me drop it a little bit. Because it is only 1,000. So it should be somewhere here. Okay, so let me show the whole graph. So this is how the graph looks like. So you could be asked in exam what each of these lines represents, what feasible area is. Now the feasible area is area inside these borders. So starting from here all the way to the top, so up to these corners. This line is something else. I will explain this later. And this one as well. Other than these, this is your feasible area, this yellow area. This could be asked in exam as well. And it could come in hard spot questions as well, where you have to point which each of the lines is or where the feasible area would be. So we have optimal point in one of these corners. We have a corner here. Let me zoom it a little bit here. So we have one corner here, one optimal point, or here, or here, or here. So any of these corners could be our optimal point. So next thing we do is we prepare something called ISO contribution line. So I've assumed 50,000 units. You can assume any units. 50,000 units of X will give me how much contribution? So if I take 50,000 units of X, multiply by contribution per unit, it's 30. It gives me 150,000 contribution, 1.5 million contribution. The same contribution, 1.5 million, will be given by how many units of Y? Dividing by 40 will give me 37,500. So the contribution that is given by 50,000 units of X is given by 37,500 units of Y. So we draw a line that goes from 75,000 units of X to 37,500 units of Y. So we have 10,000, 20, 30, and then 35, and then 37,500 would be in the middle here. So expand it as much as you can, but focus on the corners here. Now, we take this line and we drag it. When you were doing paper-based exam, you were doing this with ruler. You just took a ruler and you dragged it. So you see which corner it exits last. So you can see it has exited these corners. So they are not optimal points. It has exited this corner as well. So the last corner it exits is this one. So that is our optimal solution. So I've basically copy pasted this line here, and this is the corner that exists last, and this is our optimal point. At this optimal point, you can see we have the cross between maximum units of Y and build stage. So in our optimal point, we have maximum units of Y, which is 66,000 units. And if you take this, if you focus on this corner and you drag it to the bottom, it becomes 20,000 units of X. So if you are doing it with graph, you can just point it, or otherwise we can calculate it using equation. Okay, so the sixth step is optimal solution. To be exact, we have Y, which was already given because it was the line that was crossing. And remember, the resource line here is the build stage. The other lines are outside this corner. So the maximum available build stage is 1.8 million minutes. If 66,000 units of Y is made, it would take 20,000. The remaining will be left for X. And we take this divided by 24 usage of X. And it gives us 20,000 units exactly. So that means our calculations is correct. Okay, so the optimal solution is produce 66,000 units of X, maximum unit of X, and 20,000 units of Y. And our optimal point is this corner. They could ask you optimal point as well, where they have drawn a ISO contribution line like this, and then you have to maybe do it with your hand or something, see which corner it exits last. Okay, they ask something else. Calculate the amount of any slack resource arising as a result of optimal production plan and explain the implication of these amounts for decision making within Tablet Go. Okay, what is slack resource? Slack resource is a resource that is fully utilized. More than needed. And surplus resource is a resource that is fully utilized. The meaning is different than you usually remember. Remember, surplus is something that is extra. But here in limiting factor analysis, surplus is something that is used maximum, and slack is something that is extra. You can, if you forget it, you can remember budgetary slack. Budgetary slack is when budget is made and the resource that is put in the budget is more than that is actually required to make the budget easier. So you can remember the budgetary slack, and you can remember the meaning of slack. So in this example, the only resource that is maximum utilized is this build stage because it is on the optimal point. Other two resources, this resource and this one, which is the test time and program time, is a slack resource. If they ask you how much is slack, you can calculate it. If you look at the unit of X, there were 20,000 units. So build time, they require, we already saw it above, 24. So it is time per unit, 24 and 20. Multiplying by units, which was 20,000. And multiplying by units, which was 66,000. Adding it together. So available is 1.8 million. And you can see nothing is left. So that's why it's slack. The others are surplus. Sorry, there's no slack here. This was actually surplus, and the other were slack. But there's no slack here, yeah? So it is just, you could say it is surplus. And then slack resources, program time, $16 and $14. Multiplying by units. I can just copy this and it will work. We have 1.2 million, but available is 1.6 million. So we have a slack of 436,000 extra. For test time, we have 10 and 4. And available is, sorry, 4. Available is 720,000. So we have 256,000 slack. Okay, next thing they could ask you is calculate the share of price of a limiting factor. Remember, share of price is only calculated for surplus resource, means the resource that is fully utilized. So share of price is the increase in contribution with one extra unit of limiting factor at original price. So remember, the build program stage and test stage, there is no benefit of obtaining them extra because they are already more than we require at optimal point. So slack resource will only be calculated here for build stage. So share of price means what is the increase in contribution of one extra unit of build stage. So to find that, we do some calculation. We look at the current contribution that we are earning, which is X 20,000 units, Y 66,000 units, multiplied by contribution per unit 30 and 40. So our current contribution adding it together is about 3.2 million something. What if Y is build time is extra available? Because X is maximum level, X cannot be increased, so X would still be 66,000 units, and the time that they would require is 66,000 multiplied by 20 minutes. Yeah. And what would be left for X? Now what we are going to do is increase only one build time. So if I minus this from the top, we'll be left with 48,001. And previously, if you saw, it was 480,000. So now we have 480,001. When we take this and divide it by X, it gives us 20,000.04. So the new contribution with one extra unit. Okay, Y units are same, X units change. So we have 324,001. So if I minus this from the original one, we have about 1.25. So the shadow price of build time is 1.25, which basically means one increase in build time earns extra 1.25 contribution. So yeah, I've outlined what are the things that could be asked in exam. They could ask you what is the optimal point, like they could have named the corner A, corner B, or corner C, which resource is surplus, which resource is slack, how much of a resource is slack, how much extra is needed, which line is which resource, what is shadow price of a resource, or any of the equations above that we did here. Or they could ask you to prepare all these steps. But they will not ask you to prepare a graph, because there's no way you will be able to make graphs in computer basics. Okay, because I believe linear programming needs a little bit more focus, because some questions have some more extra points. We will look at another question as well. Okay, we have another question. A requirement. Required using linear programming, advise Benson of best mix of services to provide to maximize contribution, and then find shadow price for machine hours. Benson Company is a dog grooming service. They provide two services, Scotty and Labrador. Scotty is a short service which just involves a wash and comb and dull. Over Labrador involves wash and condition, comb, nail clip, and blow dry. Remember, I'm reading the question faster. What you could do is pause the video and take your time and read the question maybe 2 times, 3 times, however you are comfortable. Both services involve same resources, just in different quantities. The cost card for both services are listed below. So cost is given, and the selling price, material, and everything. Benson Company budgets to sell 240 Scotties and 226 Labradors per month. However, Benson Company is facing a shortage of resources over the next month. The maximum amount of specialized cleaning material is 60 liters. Total amount of labor hour available is 300 hours, and total machine time available is 150 hours. Craft will be on in next month, and Benson Company has a contract to provide 25 Scotties and 50 Labradors in second week of the month. If Benson Company does not honor this contract, it will be fined a hefty amount and be left shamefaced in the dog world. Okay, let's directly jump to the question. So what I've done is they haven't given us contribution. I've calculated contribution. Remember, we don't use contribution. We don't use profit in decision making. We use contribution. So there are two ways you can calculate contribution. One way is to take the profit and add back the fixed cost, because what contribution is contribution is profit before fixed cost. So you could just add back the fixed cost. It will give you contribution. Or what you could do is take the sales price and minus all the variable costs. But this is the faster way of doing it. And then the resources cost is given, but it is not told how much resource is used. So what I've done is taken the cost and divided by the cost per liter or per hour, and it will give me per unit. So I've already done here. You already know this from limiting factor analysis that we previously did, so it shouldn't be any problem. Okay, so first thing, we identify variables. Remember, in this question, X and Y was not given, so we need to give one product X and then another product Y. So let X be number of units of Scotty, let Y be number of units of Labrador, and let C be the contribution of X and Y. And then the objective is to maximize contribution, which is 7.5X, 15Y. C equals 7.5X plus 15Y. And then identify constraints, the limiting factors. We had material constraint, which was maximum available 60 liters, and the usage is 0.10 and 0.15. So 0.10x plus 0.15 y can be equal to or less than 60. So we do the same for other three resources. Next is labor time, which is 0.50 and 1. Can be equal to or less than 300 hours. And then machine time is 0.50 and 0.25. And maximum available is 150 hours. And then the sales constraints. Remember, there was a minimum limit as well, and there was a maximum limit as well. So Scotty minimum limit is 25, maximum 240. So they can be from 25 to 240, anywhere in between. And then Y is 50 to 226. Now we draw a graph. We do the same thing we did previously. So if Y equals 0, then X would be, for material, 60 divided by 0.10. If X equals 0, then Y would be 60 divided by 0.15. So 600 units of X to 400 units of Y. So each of the number represents 100. So we have 100, 200, 300, 400, about 1, 2, 3, 4. 4 blocks is 100. Each block is about 25. So 600 units of X to 400 units of Y. 600 units of X to 400 units of Y. So this is our maximum material I have written here. Labor, 300 divided by 0.50 and 300 divided by 0.10. So 600 1, not 0.10, it's 1. Yeah, 1. So 600 units of x to 300 units of y. Same 600 to 300 units of y. And then machine time 150 divided by 0.50 and 150 divided by 0.25. 300 units of x to 600 units of y. 300 units of x to 600 units of y. Okay, from here all the way there. And then sales constraints will be 2 lines. We had minimum x25 and maximum 240. So minimum 25 here, this line, and maximum 240. About here is 250, a little bit lower than that would be 240. So 2 parallel lines. The same thing is done with white, 50 to 226. About 2 lines here, 50 and 226 here. Now, when you have a minimum limit, then optimal point is above that limit. Let me remove this line. So this is our optimal point, above the minimum limit, below the maximum limit. Okay, just like previously, our optimal point would be any one of these corners. We have corner A, B, C, D, and E. So we find optimal solution, optimal point using ISO contribution line. Now again, let's assume 200 units. You can assume any units. 200 units will give me how much contribution? Contribution per unit is 7.5 for X. So 200 multiplied by 7.5 will give us 1500 contributions. Same contribution can be given by 100 units of Y. So the contribution that is given by 200 units of X is given by 100 units of Y. So our line goes from 100 units of Y to 200 units of X. And then we drag it, and you can see it exits these 2 corners at the same time. It exits corner B and C at the same time. So we could have a situation where we have 2 optimal points. In first optimal point, we have a cross between a maximum unit of Y and this resource here, which is maximum labor time. And then this green here is our ISO line, which is on top of that. So in the first optimal point, we have maximum unit of Y crossed with maximum labor. And if we look at the units, obviously this is 66. If we drag this to the bottom, it is about 150 units. If we look at the second optimal point, it is about 200 units of Y and about 200 units of X. Let's look at both of them, where we have optimal point with maximum units and a resource. So here in the first optimal point, we had maximum unit of Y, which was 226. And the labor time that it will take, because it was crossed between labor time is 1 hour. So the remaining total is 300. 74 would be left. So if we take 74 divided by half, it becomes 148, about near 150. So it means our calculation is right. Second optimal point doesn't have maximum units, it is this line, which is machine time and then labor. So cross between machine time and labor time. So what we do is we take the equation of machine time and labor here. I've copy pasted here. So what we do is we subtract the lower equation from the top. If they're not equal, if one thing is not equal, then you have to multiply to make it equal. So now we have 0.50 and 0.50x here, so it is okay. If it doesn't equal, then you have to multiply so that one thing becomes same, so it becomes 0. So if I minus the bottom equation from the top, what I've left here is 0x and minus 0.25 deducted from the top becomes 0.75y, and 300 minus 150 equals 150. Because x is 0, we could say 0.75y equals 150. So if I take 150 and divide it by 0.75, it will give me how much is y, which is 200. And you clearly saw that it was 200 here. Now let's see how much is x. Look at it for both. So if we look at y here, because y is found first, machine time that it will take is 0.25, and the extra time that would be left, total time, remember, is 150. So minus that, 100 is left, and then taking 100 divided by the units of x, usage of x, which is 0.50. 200 units of x. So which means our calculation is correct. If we look at the labor time as well, it will give us the same result. So labor time required by y is 1. And if we take 300 minus 200, what is left is 100, and then 100 divided by 0.50 as well. We have 200 units, which means our calculation is correct. And then they could ask you to calculate the share price. Remember, you just change it in the equation, and then you recalculate the equation, and you find new units and find the share price. I believe this is it for linear programming.